So in last lessons, we looked at naming these different compounds. And one thing I did say is that if it starts with H, it's an acid. And you've got to get used to this. So in chemistry, we've got to do two things. What do we mean by an acid and alkali? But moreover, how do we write them down? How do we work with them? So we're going to do a mix of things today. So looking at these, there are what we call, there's a very old term that I use called bench acids and alkalis. Now I'm talking about bench acids first. These are the things that we use in school, and we do titrations with them, we do experiments with them, and they're on here. So we have hydrochloric acid. This is a strange one. It is the one with probably the hardest kind of name to associate with what we call salts. We might have a look at them today, if not next session. But it's the easiest acid to really work. We've got sulfuric acid and we've got nitric acid. These are your bench acids that you will use. Nitric acid. That you'll use in a science lab. Now, we've also got bench alkalis. Again, these are things that we do experiments with. I'll put them over here, bench alkalis. Bench alkalis. And the kind of things that we will be talking about when it comes to bench alkalis are hydroxides. So we're talking about sodium hydroxide, lithium hydroxide. And if we pay very close attention to this, the way you name a hydroxide is a metal, then a hydroxide. Okay, so these are the things that we use in a lab. And they're really cool. These are what we call strong acids. We'll look at why they're called strong acids in a while. But what I wanted to do really was mix it in with key stage 3. And what we have with key stage 3 is acids and alkalis you find in the home. Some of these you can play around with. Some of these are dangerous and don't, right? And what I would always say is, if you are thinking, and you're not experienced with these things, and I don't mean that as a criticism, I really don't. You're new into the area of learning about real tough chemistry. So always with your parents, say, right, I want to try this, can I? So, and you'll see what I mean by some of these acids and alkalis you can work with. And these are in the home. So you've got a whole host of different things here. So you've got vinegar, toothpaste, baking soda. I'm assuming some of you have baked cakes. I think my son was about 8 when he baked his first cake. You've got soaps, lemons, oranges, all these things you can, tinker with. Hopefully you don't drink Coke, which is phosphoric acid, which is really horrible for yourself, but that's me just preaching. All right, and tomatoes. The things on that picture that I'm going to turn around and say, right, you know what, stay clear away from, do not touch, are things like bleach and oven cleaner. They're very dangerous. But I'm sure if you want to do something with lemons, and there are really interesting things you can do. You can actually turn a lemon into a cell, a light bulb. That's a different, a tiny little bulb. That's really interesting. So we categorize them as acids and alkalis. So you have this kind of key stage 3-ish definition of a alkali. There's nothing wrong with it. They turn around and say acids have a sour taste. Yeah, they do. We know it's like when we chew into a lemon or vinegar. Alkalis have a soapy texture. Don't eat them. Right? Yes, you brush your teeth with toothpaste, and don't eat bleach. Stay away from oven cleaner. Right? Most of these things, right? If it's not a fruit, the way I would say to you guys is, if it's not something you normally eat, don't touch it. Don't shove it in your mouth. Right? And I think you get a lot of YouTube videos now where they're doing things and you're just thinking, that's not clever. So this is a key stage 3 definition, and now I'm going to add a key stage 4 to it. Acids give off H plus ions. All right. So all acids, I'm going to put it over here, back up there where I was writing. If you have acids, they produce H plus ions. That's when you drop them in water. When you put them into solution, they produce H plus ions. Alkalis produce OH minus ions. All right. So that's a little bit of key stage 4 in there. These are acids and alkalis. So now moving forward with this, the next thing we're going to talk about is, safety wise, if you ever get a chance to work in a lab with acids or alkalis, be careful. The one thing I do say is always wear goggles. All right, always. I don't care what it is. All right. So anyway, how we categorize acids is concentrated or dilute. Concentrated acids are very dangerous. All right, you don't have them. You will not have them in your house. They are not available for sale. So yeah, they can be pretty dangerous. If you take these and actually drop it in water, it's an exothermic reaction. It can get very hot. Now, dilute solutions are fine. You find acids, I'm talking about acids and alkalis, in dilute concentration. For example, vinegar. All right, that's a very weak acid and it's dilute. All right, so next bit. Let's move forward. I've done that. Okay, now this is the pH scale. So a pH scale, and I'm sure some of you have seen this before, tells you how strong an acid or an alkali is. Now, water sits in this domain. Water is neutral, it's a pH of 7. Okay, now I'm talking about pure water. I'm not talking about the things that come out of your tap, that's slightly lower, slightly higher, but pure water has a pH of 7. These colours are from a piece of litmus paper. You can get a hold of litmus paper and you just dip it into a solution and it changes colour. The more acidic it is, it's on the left-hand side. So pH of 0 and 1, this is a strong acid. Vinegar is about pH 4, so that's like amber. Then when you get to alkalis, you're going from a pH of 8 up to 14. And that range is something you need to know for key stage 3 and key stage 4. Now, I'm going to add a bit of key stage 4 to this. This is what we call a log scale. All right? What that means is these are not normal numbers. A pH of 1 does not mean that it's, twice the strength of something that's a pH of 2. What it actually means is each number you go up, its strength increases tenfold. That's what I mean by a log scale. And it is true for the Richter scale as well for earthquakes. So a pH of 1 is 10 times stronger than a pH of 2. A pH of 2 is 10 times stronger than a pH of 3. So something with a pH of 1 is 100 times stronger than something with a pH of 3. And a way of looking at it is the number of zeros. All right. So if I've got a pH of 1, I'll put it there, and a pH of 6, the difference between pH of 1 and pH of 6 is 5. So 6 take away 1 is 5. That would mean that's the number of zeros. It is 5 zeros, 10 or 100,000 times stronger. So a pH of 1, an acid, is 100,000 times stronger than a pH of 6. Right? That's what we call a log scale. We're not really going to work with a log scale today. That's something we do up in year 11. We'll do a tiny bit of work in year 10, year 11, tiny bit of work in it, but not much in year 9. Okay. So, strong acids to your left, mild acids or weak acids or 3, 4, 5, and 6. Weak alkalis 8, 9, 10, 11, and strong alkalis 12, 13, 14. All right. So, as I said, we measured things. I've got both of these at home. This is litmus paper or universal indicator. You just drop them in and look at the colour change. All right. And it's really that simple. Okay. This is an experiment, and I'll talk to you about independent and dependent variables after we start this session. All right, I'm just going to stop that.